Welcome to your algebra videos. This will be your first one. This is Unit 1-1, as you can see right here at the bottom. You'll notice it says Holt Lesson 1-5. That simply means Chapter 1, Lesson 5. That's where we'll be starting. And the little A there implies there's going to be a Lesson B that's going to follow it pretty soon. This is called Roots and Irrational Numbers. Roots and Irrational Numbers, as you can see down there. So here, let's take a look first of all at something we'll just label here what's expected. You're going to see some icons here on the right hand side, and during the lesson you'll see them up in the upper right hand corner on occasion, so take a look for those. Maybe the most important thing beyond anything else is try to limit your distractions. So maybe for, it's going to be about 10 minutes here. Set aside your phone, your music, your Facebook, whatever you're doing that's distraction. Just go ahead and give the lesson a good 10 minutes and concentrate here, and you'll get a lot out of it as you go through. And if you can just make that a daily practice. I know that distractions are easy to come by at home. I have a lot of my own, so sometimes I just have to kind of focus and try to get that done while I can. So also occasionally you're going to have this paper and pencil here. You'll need to take down some information. We'd like you to be able to do that and put that into your notebook. In almost every lesson there's going to be some practice problems. These practice problems, you'll see this guy here with his chalk and working on a board. We'd ask you to put those inside your notes as well. And then after every lesson, we'd really like you to write down one question. You can write down more than one if you'd like, but just one question that you might have about the lesson, something that you want answered. And if you're absolutely rock solid on it, then just give us one that maybe we can ask some other students, in the class, a math problem or something. So once again, if you see these, you see this icon here, this means watch only. So the guy with the binoculars, just watch, don't do anything, no stress, don't have to write or do anything there, just watch. Add these to your notes if you see the pencil and paper, and of course add the practice problems. And I'll be drawing your attention to these for the first couple of lessons so we get used to seeing them. Here's our California standard. This will be in every lesson we have. This will students use and understand such operations as taking the opposite, using exponents, and finding reciprocals. Standard 2.0. Specifically, our objective today is we're going to learn to simplify roots and identify irrational numbers. Simplify roots. Simplify just means to make smaller. Roots you're already aware of. If I say square root, that'll probably ring a bell for you. And then we can identify irrational numbers pretty simply, and I'll show you how. Now here's our vocabulary. You don't really have to write anything down here. We'll just get used to using some stuff, especially the last two here, radical and radicand. It's not going to be a vocabulary test per se, but we'll be using these words quite a bit during our lessons. Alright, so let's start with this. A number that is multiplied by itself to form a product is a square root of that product. Now, that's a lot of math words there, and sometimes they can get mixed up, and I read them and I'm like, what are they saying? So I like to use just an example. So what they're saying here is if you have 5 and you square it. Remember the exponents from previous math classes? This is 5 to the second power. Well, 5 times 5 is, of course, 25. It's not 5 times 2, it's just 5 multiplied by itself twice. And here, this is the inverse. And the inverse of squaring is taking a square root. You'll see this little radical sign here, which is what we're going to call a radical sign, or the square root symbol in this case. The square root of 25 in this case is 5. Now, some of you may recognize that there's more than one answer here, but we're just going to be talking about the principal square root. So if there's no sign in front of our radical sign, we're just going to be considering it the principal square root of that number. So principal square root of 25 is indeed 5. Finding the square root of a number is like doing the opposite or inverse of squaring the number. Okay? Alright, very good. Moving forward, the radical is another name for the square root sign. Now in this case, you'll notice that we have this blue symbol here. This is called the radical or radical sign. And we're going to see a little alteration to this in just a minute. When we put a number inside of it, this number here is called the radicand. So in this case, 144 is the radicand. So the radicand is the number under the radical. What we're really saying here is what number multiplied by itself gives the number inside the radical. So if we have the square root of this 144, can you think of a number times itself that's 144? Well, probably you've already answered. The number is 12. So we know that 12 times 12 is 144. So the square root of 144, or radical 144, is just 12. Alright, now you see a little guy here with just the watch. Just watch this. Don't have to write anything down. A perfect square is a number whose positive square root is a whole number. And some of these you already know. If I put these up here real fast, I'm pretty sure you can get most of these. Maybe we'll go over here and grab our pen and we'll see about putting an answer or two here for you. For example, how about the principal square root of 36? Would you agree that is the number 6? Okay, good. How about 100? 100, well, what times what is 100? I'm just going to go with 10 here, principal square root. And what about 49? Well, the principal square root of 49 is, of course, 7. And I'm pretty sure you can fill out the rest there on your own for the most part. And if not, we'll be going over some of these pretty soon together anyway. Now, not all square roots are perfect squares. In fact, most are anything but perfect. So, for example, we know the square root of 25 is going to be positive 5 is one of the answers. But what about this? What if we had the square root of 12? So 12, there is no whole number, or should I say integer, that if you multiply it by itself is going to give you 12. So we get this really strange looking decimal if you were to punch that into your calculator. Remember that these dots here, what it implies is there is no termination. These numbers just continue on. If we look at another number like 24, square root of 24, and even radical 50, even though there's no dots here, you get this really awkward number, and we call these irrational numbers. Irrational numbers. Now, it's not because they're crazy or anything. Rational simply means we're dealing with integers in a fractional form, some integer over some integer. An irrational number doesn't allow us to do that. Now, the cube root asks, cube root. Well, we talked about square roots. What's this cube root? Well, a cube root says, what number multiplied by itself 3 times? 3 times. Remember, a cube, if you think about a cube like a die that you would roll on a table or a sugar cube, it has length and width and height. So there's actually 3 dimensions to a cube. So we're going to actually change our index here. Remember before it was blank? Well, whenever it's blank, we just assume there's a 2 there. But because there's a number that's called the index has been changed to a 3, we want to find the cube root of 125. So can you think of a number multiplied by itself 3 times to get you 125? So let's consider something times something times something is 125. Well, if we start, let's say something pretty basic like 5. 5 times 5 times 5 is indeed 125. Note down here 5 times 5 is 25. And if you have 25 cents and then you have, let's say, 5 quarters. Well, how much is 5 quarters? It's $1.25. So there's your 5 times 5 times 5, or 5 to the 3rd power is 125. Inversely, the cube root of 125 is 5. All right. Think about this for a second. The cube root of -8. Cube root of -8. Now, this actually has a solution because we're looking for a number multiplied by itself 3 times to give us a negative radicand. Now, we can never do that with a square, and we'll get to that in a second. But with a cube, we can. So, for example, if we took -2 times -2, well, that's positive 4, multiplied by -2 again, well, that's -8. So there you've got a negative times a negative times a negative, gets you back to a negative there. So what's the cube root of -8? Indeed, it's -2. So consider this. Why can we take the square root of we can take the square root of a positive number, but we cannot take the square root of a negative number? Well, the reason being is squaring a positive number or or a negative number always gives you a positive answer, never negative. So, for example, if I were to take my little trusty pen here, and I said something like 3 squared, well, that's going to be 9. But what is -3 squared? Well, -3 times -3 is still positive 9. I never get a negative result here. So whenever you square a non-zero number, you're going to end up with this positive value. The only exception is, of course, 0 squared is still 0, which is not positive, but it's not negative either. Okay? All right, very good. Okay, now these here, here's a list of numbers that you really have to know. So here is where you can control the video some. You can just easily go over and hit your space bar and press stop and jot these down and try to fill them out. What I'd like you to do is try to fill out as many as you can. Now, of course, I'm going to give you the answers here in just a second, so you don't have to stress over it. Don't worry about grabbing a calculator and figuring it out. just write down which ones you know. So maybe you know 12 squared is 144. We talked about that already. Maybe you know 20 squared. You can kind of intuitively look at that. 2 times 2 is 4. You should have 2 zeros. How about 400? And write down the other ones that you might know. Maybe you could look at the back of your agenda, you know, the one that the school gave you, and take a look there and see if you see a square root table in there. I'm not sure if they are anymore. Back when I was in school, we had them in the textbook. But now they have calculators. So write down the ones you might know. And let's see. Go ahead and pause the video, take a look, and then I'll come back to you with you here in just as soon as you're done. All right, then. We're going to assume that you finished, or finished as many as you wanted to or could. So let's go ahead and fill our table out here. 11 squared, 121. 12 squared is one we already talked about there. How about 13 squared? 169. 14 squared is 196. 15 squared is one that's pretty common, 225. And I'll go ahead and fill in the right-hand table here. 256 and 289. 18 to the second power is 324. And then the aforementioned 20 squared is 400. How about 25 squared? Did you end up with 625? Now these we're going to expect you to know. They're going to be on benchmarks and different things like that. So maybe you can kind of start applying these and committing them to memory and see what you can do with these as you go forward. Okay? No anxiety right now about memorizing, but just get used to using these basic numbers here. All right, now how about you take a turn? Notice the guy up here with the chalkboard, and he's going to do some work for us. So how about this? Go ahead and take a look at radical 36. We could also say square root of 36, or high school teacher would say principal square root of 36. There's no negative sign in front, so we're just looking for the positive value, and I'm sure you got 6 by now, right? How about this one? Square root of 25. Well, we know that's 5 from earlier in the lesson. How about this one? A little bit tougher now. Cube root of 8. So what I want you to do is think about a number multiplied by itself 3 times to get to 8. How about 2 times 2 is 4, times 2 again would be 8, correct? So the cube root of 8 is 2. How about this one? Square root 81. Square root 81? That's correct. It is 9. Very good. How about this one? Square root of 121. Well, we just saw in the previous slide there, something squared is 121. Remember that something? That something's 11. How about this one? Cube root of 27. A little bit tougher here. I'll give you a second to think about that. Cube root of 27. What times what times what is 27? How about 3? Very good. 3. Radical 49. Pretty easy. 7. How about square root of 64? The principal square root of 64 is indeed 8. Radical 196. 196. Think about your list. Did you come up with 14? Good. And how about square root of 400? Well, we're just taking 20 squared, working backwards there. The inverse would be 20. All right then, so there's your list of solutions there for those pretty straightforward square roots. Hey, we got one more. Look at that. The cube root of 64. I forgot about that guy. Cube root of 64. Well, we know that 8 times 8 is 64. Can we think of a number times itself 3 times? Well, we know that 2 times 2 times 2 is 8. That's not good enough. 3 times 3 times 3 is 27. That's not good enough. What about 4 times 4, 16? What's 16 times 4? Well, that's 64. So what's the cube root of 64? The number 4. All right, now that is the conclusion of our Unit 1-1. In every one of these, I'm going to go ahead and let you know that if you'd like more instruction, this is your textbook website. It was bought and paid for by the district when we got your books. You can go ahead and log into thinkcentral.com, and the brilliant people who wrote the textbooks, I mean, much math information there with those people. They would develop videos for every lesson as well. You can go to this website, type in this code, and then watch video example 1. That'll cover this lesson in particular in a different way. So if what I said was confusing or too fast or something that didn't really stick with you, you can watch that. It's a very brief video, probably under 3 minutes, and they'll be able to help you out there. Also note, make sure that you reflect on what you have just learned. Write down one well-considered question to ask in class. Okay? So maybe you volunteer, maybe I call on you. We'll see. All right then. We'll talk to you soon.